all about strong chemical bonding, and we start with ionic bonding. Do you remember what an ion is? What is an ion? Right, an ion is a charged particle, right? So an ion can be elemental in that you've got an atom that either loses or gains an electron to become an ion, right? Or we can have what's called a polyatomic ion. So poly means many. So polyatomic means many atoms. Ion means charged particle. So it is a charged particle that is made of different types of atoms that are joined together. I will get to it. Okay? So I'll write it on the board as well. So here's our success criteria. So polyatomic ion. So you've got an elemental ion, right? Right, so example, sulfide, right, or so the sodium ion, right, or we've got what's called a polyatomic ion, right, poly means many, right, so that means atom, and ion means charged particle. So e.g. sulfate SO4 2 minus of hydroxide of H minus. Capitals and lowercase letters are really important that we're getting the formatting correct. Right, so I may have said this before, I'm not a stickler for spelling or for grammar in science or chemistry. I am a stickler for formatting, right, because formatting matters. Right, is a charged particle made up of more than one atom. Okay. Right, so we want to determine defining the term valence electrons. We already know what that is. What's a valence electron? The outer shell electrons, awesome. State the number of valence electrons in the main group elements, groups 1 to 2, 13 through 18. How many electrons in group 1? Group 2? 2. Group 13, how many? Group 15, how many? 5. Group 17, how many? 7. Group, so what did I say? Group 15, 5. 17, 7. Group 18? 8. Awesome. Identify the types of atoms that form cations and anions. We'll talk about those. Question? Nothing? Cool. Draw the electron shell diagram for the formation of cation and anion. Describe why ions are stable. State the type of bond formed between an anion and cation. The ionic bonding model we will look at. We want to be able to draw and label the bonding model. Describe the transfer of electrons and describe the ionic bonding model. We want to be able to look at the properties of ionic compounds, listing main properties, and describe how we can use that to explain the properties. The last part of this section of the bonding model is stating formula, stating the formula of ionic compounds formed from polyatomic ions, and stating the name of ionic compounds as well. So formula relating to simple and polyatomic ions, and stating the name of those compounds as well, when we're involving transition elements. Okay, so we'll talk about that later. Let's go to the first part of this unit. Valence electrons that we've discussed. They're the electrons that occupy the outermost shell. The group number helps to determine the number of valence electrons. So group 1 and 2, 1 and 2 electrons respectively. 13 to 18 have 3 to 8 electrons respectively. Cations and anions. So let's think about this from a definition point of view. Ion means charged particle. If we put the prefix cat in front of it, it means positively charged. So, a couple of ways to remember this. We can either consider a giant plus in between, right? So if we change the T to a plus symbol, cation is a positively charged particle. Or we might want to consider that it is positive. Yeah? We think about that. That's 4. Anion, my way of remembering that, is the prefix a or the prefix an means not. Right? So if we think about atheist, right, is someone who does not believe in God or a God. So theist is someone who believes in a God. Atheist does not believe in God. So if cation is positive, then anion is negative, or a negative ion is one way we can remember it. The type of atoms that form cations and anions, metals will form cations, right? And non-metals will form anions, generally speaking. Metals form cations because they have 1, 2, or 3 electrons in the outer shell, which means that it's more easily able to lose those electrons than it is to gain 5, 6, or 7 electrons. I mentioned that idea of the octet. Oct means 8. 8 means stable when it comes to an atom. Non-metals will gain electrons. Right? Electrons are negatively charged. So if we're gaining more negative, we become negative. If we lose negative, we become more positive. Does that make sense? Yeah? Any questions on that? Good? Okay. Let's consider about their formation. So cations form from the loss of valence shell electrons. So if we look at the sodium atom, right? So here we've got the Bohr model, 2, 8, 1 is our electron configuration. Right, so 2 and 8, they're full shells. Shell 1, we can fit 2. Shell 2, we can fit 8. How many can we fit in the third shell? Remember, it's how many we can fit into the third shell. Yeah? 32. 32 is the fourth shell. So the third shell is how many? 18 is correct. Octet. Oct means 8. We want 8 in our outermost shell. I've got 1 in the outer shell. So is it easy to lose 1 or gain 7? Lose 1. Okay, so sodium, or our group 1 metals, are going to lose 1 electron. What do you notice about the size of the ion in comparison to the size of the atom? Right, so cations are smaller. We don't really look at atomic radius, but I guess for a little bit of extension, we can consider that as we lose electrons, the atom becomes smaller. If we gain electrons, what do you expect will happen to the size of the ion? It will increase in size. There we go. Fluorine atom, 2. Uh-oh. I've stuffed that up. It should be 2 and 7. I've got too many electrons there. Let's fix that up. Yeah, I'll fix that up later. But it should only be 2 in that first shell, not 6. Delete that. Okay, so it's fixed up. Right. I'll put these up on canvas later today. So, fluorine atom, it's got the electron configuration 2, 7. Remember, when we get to each subsequent shell, we start to fill singly, and then we pair up. So notice we've got 3 pairs and 1 unpaired electron. So it wants to gain an electron. Right, so now we get the configuration 2,8. And the ion, or the anion size, is slightly larger. 9 protons, 10 neutrons in the atom, in the nucleus. Notice how the name slightly changed too. We go from a fluorine atom to a fluoride ion. Now, I said I wasn't particular about spelling, right? There's a few exceptions to that. Fluorine and fluoride are not the same thing. Sulfide and sulfate are not the same thing. So that's where spelling does matter. I've mentioned this idea about the octet. There's something about the octet that has stability to it. So ions will form such that their octet will be complete. So whether that means they lose some because their inner shell electrons are already full, or whether they gain some so their outer shell becomes full, that helps them to become more stable. So if we've got less than 4 electrons, we're more likely to lose the electrons. Right? If we've got more than 4, we're going to gain electrons to get up to 8. 4 electrons, which is quite interesting, neither gains nor loses. So when we get to 2.3, right, when we talk about covalent bonding, that's when we get to that. When we get to 4, we've got a half-filled shell. So it means that we're just as easily like to lose as we are to gain, so they're more likely to share in order to complete their octet. 8 electrons in the valence shell, noble gases, are already full. And so our monatomic ions actually have the same electron configuration as their nearest noble gas. So the sodium ion, sodium atom, will have the configuration 281. Sodium ion has a configuration 28 that happens to be the same as neon. We look at sulfides and sulfur. A sulfur atom, or S, has the configuration 286. Sulfide has the configuration 288, which is the same as argon. Pause that. As you can see, you're all madly typing along. I mentioned this idea, so a bit of extension if we're wanting to look at ionic radii. So particularly if you're going into the IB next year and wanting to do chemistry, right, ionic radii is something that we explore. So we can see that, right, the ionic radii of cations is much smaller, right, and the ionic radii of anions is much larger than the original atom. Right, and that relates to core charge, which is this concept about the strength of attraction of those outer shell electrons that are being pulled towards the nucleus. So if we've got more negative charge, right, there's less effective core charge, and so therefore those outer shell electrons will expand. If I've got less electrons, it means that we've got a greater force of attraction of the other electrons remaining towards the nucleus, and so it pulls in. State the type of bond between an anion and cation. Well, this whole part of the unit is called ionic bonding. So the name of the bond is ionic bond. If we want to consider a bit more detail about that, it's called an electrostatic force of attraction. In fact, all bonding is electrostatic, but it differs in some manner. Let's break down the word. What does static mean? Static sort of means still, stillness. Right? So stasis means still. Electro, right, refers to electrons or charge, really. So in the case of ionic bonding, it's the